Laws of exponents. There are three laws of exponents that we're going to go over. The first is multiplying powers with the same base. And before I give you the law, I want to show you some examples of how you can remember it. 5 to the fourth times 5 cubed. That means 5 times 5 times 5 times 5 times 5 times 5 times 5. If you were to count up how many times that base is repeating, you would see that it's 1, 2, 3, 4, 5, 6, 7. 5 to the 7th. Over here, a squared times a to the fourth. That's a times a times a times a times a times a. The base of a is repeating 1, 2, 3, 4, 5, 6 times. So this is a to the 6th. If you notice, 4 plus 3 make 7, and 2 plus 4 is 6. So the law for multiplying powers with the same base is when you multiply powers with the same base, you add the exponents. So let's go ahead, multiply, and write using a single positive power. So x to the 12th times x to the 12th. Same base, add the exponents. 12 and 12 is 24, so x to the 24th. 16 to the first times 16 to the negative 7th. 16 is the base, add the exponents. So 1 plus negative 7 is negative 6. But remember, the directions say to write using a single positive power. So make the number a fraction, and the exponent is negative in the numerator, so you move it to the denominator to become positive, 1 over 16 to the 6th. And since it says write using a single positive power, you do not need to multiply 16 6 times to find this answer. 4 squared times 3 squared. Well, remember the law. It's multiplying powers with the same base. 4 and 3 are not the same base, so we cannot combine this using the law. However, you could combine this if you multiplied 4 squared, 16, and multiplied that by 3 squared, which is 9. But with the law, this cannot combine. Our next law is dividing powers with the same base. And again, I want to show you how you can remember this. If we have 5 to the 5th over 5 cubed, that means 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5. When you have a fraction and you have factors in both the numerator and the denominator, they can cancel out. So 5 and 5 cancel, 5 and 5 cancel, 5 and 5 cancel. That would leave us 5 times 5 in the numerator, which is 5 squared. X to the 7th is x times x times x times x times x times x times x over x times x times x. Again, we have factors in common, so these x's cancel out, and we're left with x to the 4th in the numerator. If you see 5 and 3, if you subtract them, you get 2, and 7 minus 3 is 4. So the law for dividing powers with the same base is when dividing powers with the same base, subtract the exponents. So let's go ahead and divide, write using a single positive power. 10 to the 8th over 10 to the 5th, same base is 10, and 8 minus 5 is 3, so 10 to the 3rd. X to the 4th over x to the 9th, the base is x, and 4 minus 9 is a negative 5. We have to write it with a positive power, so make this a fraction, and the exponent is negative in the numerator, so we're going to move it to the denominator to become positive, 1 over x to the 5th. Another way to think about this is if we use that method of writing out all the x's. And cross them off, we would end up with 5 x's in the denominator. So you could just subtract 9 minus 4 and get 5. And if you remember that there's more x's in the denominator, it'll be 1 over x to the 5th exponent, whatever you're more comfortable doing. And in our last one, once again, 7 to the 5th over 5 to the 7th, we do not have the same base, so using laws of exponents, we cannot combine. Our last law is raising a power to a power. So 7 squared to the 3rd. That means 7 squared times 7 squared times 7 squared. List it out, that's 7 times 7 times 7 times 7 times 7 times 7. The base of 7 is repeating 1, 2, 3, 4, 5, 6 times. 7 to the 6th. Over here, b cubed to the 4th power is b cubed times b cubed times b cubed times b cubed. So that's b times 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 b. And this base of b is repeating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And hopefully you have seen the pattern. 2 times 3 is 6, and 3 times 4 is 12. So when you raise a power to a power, you keep the base and multiply the exponents. So let's go ahead and raise a power to a power, right, using a positive exponent. 8 to the 5th to the 4th power, it's going to be 8 to the 20th. 2 to the negative 7th to the negative 2. Don't worry so much right now about the negative exponents, just go ahead and multiply them. A negative 7 times a negative 2 becomes a positive 14, so it's 2 to the 14th. X to the 10th to the negative 6th power. Again, just multiply 10 and 6, that's negative 60. So x to the negative 60. And now go through and change the exponents so that they're all positive. So this would be 1 over x